Hi everyone, welcome to the first lesson for topic 3.2 Growth and Decay in Sequences. So this is a new topic which is the second topic in our unit 3. Okay, let's look at the title first. So growth and decay. So the word growth basically meaning something that's increasing, so that's like increase. Decay meaning something that's like decreasing, so decrease. In sequence meaning that the increase and the decrease actually occurs based on a certain rule or a certain pattern. Okay, so which means we're going to learn how do we apply or how do we model the situation that's given by using some specific rule. Okay, so let's look at the learning outcome of today. So we are not moving into any real content of this topic yet. So this lesson serve as like a basic knowledge or a foundation before we move on to the real content. So for today's lesson, we are going to discuss about these two main ideas. The first one is called as sequence. The second one is recurrence relation. So you'll understand what is the concept of these two ideas. Then how are you going to write some notation by using the right terminology? So meaning how do you specify, how do you write a term? Then how are you going to write the relationship between the terms and so on. And we're going to solve some question together. Then for the second part, after we solve all the questions, then we'll be using our calculator to help us to generate the relation and to check our answer. Okay, so I hope that for this lesson, right, there are there will be questions that will be coming out in like calculator free session. So that's why I hope that throughout this lesson and when you are trying the exercise under this lesson, right? So you can, for this lesson, you can always try to use mental calculation rather than always rely on your scientific calculator. So it's a good time for you to practice like your mental calculation starting for now, especially for this chapter. We are not moving into a very difficult part yet. So for all the easy sequences that we are going to discuss under this particular lesson, you can always try to use mental calculation. Okay, so let's start with a quick overview of the topic. Okay, so there are going to be five main parts of the topic here. So for today, it's going to be like the first part, so which we discuss some of the basic concepts, so some of the terminology that I think is helpful for you to know before we move on to the real part of the lesson. Then for next week lesson, we are going to look at the special sequence that we have. So the first one is called as the arithmetic sequence. So I guess maybe IGCSE not, but if let's say you are taking SPM additional mathematics, you should be quite familiar with the term arithmetic progression. Okay, don't worry, it's not a very difficult idea. It's just that you need to know after this. Okay, so the second one is the other type of sequence that we are going to learn, which is called as the geometric sequence. Okay, so geometric sequence. So you can try to write down first so that you know what are the things that we are going to go through for this lesson, right? Then after that, the last one, we are going to talk about first order linear recurrence relation. First order linear recurrence relation. We're going to touch some parts of this for this lesson actually as well. But no worry, we are going to repeat that anyway. But yeah, some of the part actually we are discussing about this. It's just that maybe I'm not explaining the part for what is that meant by first order linear. Okay. Then after that, the last one, we are going to spend some time to look at question. So to understand how do you model and how do you apply all these idea into the question. So that's the most important part. Okay. So as what I said, when you heard of the subject itself, mathematics application, meaning that what's the most important for this subject is actually the application. So the theory part can be super easy, but it's whether you are able to apply what you learn in the real situation or not. Okay, so that's the main thing that they want to test you, especially in your exams. Okay, so let's start with our first part of lesson, which we will be discussing about sequence. All right, the idea of sequence. So a sequence is an ordered list of numbers or objects. Okay, so for these topic, we are going to focus in the part for numbers. But normally we can do objects as well. For example, like A, B, C, D, E, then F, G, and so on. Okay, so it's like a list of number of or objects which is in order. So this is like the main point for sequence. Okay, so let's try to like fill in a blank, like a very easy one. You can pause the video and try yourself, or you can just try to go through together. So I think this is super easy. So for like the first sequence, you can see 2, 5, 8, 11, 14. So you should be able to identify it like very quickly. So it's by adding 3 for each term. Am I right? So that's why 14 plus 3, 17, 17 plus 3, 20. Okay. So again, make sure that you are practicing your mental calculation. Do not use your calculator. Okay, then after that, the second one. So 80 to 70, 65, 50, 35, 20. So you should be able to realize that the difference here is like 15 for each term. Okay, so it's like subtracting 15 from each of the subsequent term. So after 20, then minus 15, then you will get 5. So again, 5 minus 15, then from there you can get negative 10. Okay, so let's move on for a second. Next part. 5, 10, 20, 40, 60. Yeah, so you realize that what happened here is multiplication. Okay, so times 2. Then this is how you can move on, right? So 5 times 2, you get 10. 10 times 2, you get 20. Times 2, 40. Times 2, 80. So same thing, 80 times 2, so we can get 160. 160 times 2, so 320. Okay, so the next part, 1, 4, 9, 16, 25. Okay, this is slightly harder, but you should realize that all this number is like perfect square. So perfect square as if it's the square number that you get after you square a integer. So for example, 1, you're getting it from 1 square, 4 from 2 square, 9 from 3 square, 16 from 4 square, and so on. So 5 square, so this will be 6 square, right? So that will be 36. So 7 square, that's going to give us 49. Okay, so the next part, 5, 11, 23, 47, 95. Yeah, this is a little bit tricky as well. So yeah, why not you can spend some time to think about it first. Yeah, so let's try it out. Okay, so you can see from 5 to 11, the difference here is 6 plus 6. 11 to 23, what's the difference here? Plus 12. 23 to 47, yes, is plus 24. 47 to 95, okay, don't use your calculator, so try to think and see. Yeah, 47, 95. So that's why, yeah, 15 minus 7, then you can get 8, then 8 minus 4, then you can get 4, right? So you realize that the difference between all these terms is like double up every time. From 6, then times 2 you get 12, 12 times 2 you get 24, 24 times 2 you get 48. So that's why when we move on, then it will be plus 96, right? So it's not too hard yet, right? 48 times 2, so 96. So I plus together, so 11. So that's why you have 191. Okay, then after that, we move on. So what's the double for 96? So 96 times 2, so you can get 2 at the back. Then after that, add in 1. I feel like I'm like teaching primary mathematics. Okay, anyway, so 12, and then you can get 2, 9, so that's why it's going to give you 192. Okay, so or you can just do 96 plus 96, it's just the same thing. So when we plus together, then we can get 383. Okay, so that's the idea for this sequence. Okay, the next one, this is a special kind of sequence as well. It's called as Fibonacci sequence. So you can actually search it out in the internet as well. So this is one of the special kind of sequence that you can see, right? How do you get each term? Actually, we can observe start from here. So 2 is the sum for 1 plus 1. So it's the sum of the first two terms. How do you get 3? It's the sum of the previous two terms as well, 1 plus 2. How do you get 5? It's like the sum of the two previous terms, so 2 plus 3, right? So how do you get 8? It's like 3 plus 5. So which means that for each of the subsequent term, it's the sum for the previous two terms. So you get 2 from 1 plus 1. 1 plus 2 give you 3. 2 plus 3 give you 5. 3 plus 5 give you 8. So now when we continue, then it will be 5 plus 8 give us 13. So 8 plus 13 gives us 21. Okay, so yeah, that's the idea. Okay, so now you see, right, for each of the sequence here, so we are calling it sequence because they are in an order, right? So that's why you can see that you can basically guess the next entry without me telling you that what is the pattern here. You get what I mean, right? Just by looking at the list, I didn't even tell you that it's adding 3, but by looking at the sequence, we are able to actually guess what is the next entries after that. Even after 20, after -10, you will be able to do that. Am I right? So why can we do so is because of they are a certain sequence that we can follow. Or in other words, there's like certain rule that we can try to follow. Okay, so that's why we'll be able to guess the next entry. Okay, so now let's look at the part for the notation. Okay, so rather than naming the number in the sequence, normally we'll call each number as term. Okay, for example, this is a sequence of like the one that we have it here just now. Okay, so you can see it's like plus 6 plus 12, 24, and so on. Okay, so as we can see here, so instead of calling this as 5, we can try to denote it as this is called as the first term as well, right? So the first term of this sequence is 5. The second term for this sequence in is 11, and so on. So this is like first term, second term, third term, fourth term, fifth term, and so on. Okay, but you'll realize that it's pretty hard for us to, I mean, that's very helpful in verbal, but I mean, you're not going to write it like every time. It's like very hard. It's a very long process to write like first term of the sequence is 5, second term is 11. You get what I mean, right? So that's why we'll try to define it by using some mathematical notation. Okay, so let's do a first one, which is the most common one, which is the one that used in your textbook as well. So rather than call it as first term or writing it as first term, we will try to write term 1. So which is the first term lah. So which is T1, subscript 1. Okay, so for second term, then it will be T2. And then the third term, it will be T3. Okay, so please remember that the ABC is basically a labeling. That's it. So you see, right, if let's say I try to denote that my sequence is A, then which means that I can always define my term by using A1, A2, and A3 as well. So it's just a labeling. What is more matters is the order. So it means that if let's say this is like term 1, term 2, then you can't write that this is T2, this is T3 lah. You get what I mean, right? Yeah. So what matters is the order. So that's another way that you will be seeing in some of the exercise that I'll be giving you in the future as well, which is they try to write it in a bracket. Okay, so that's the way that we'll try to use it when we try to generate the sequence in our calculator as well later. Okay, so sometimes you'll write like this term, then bracket 1. So instead of like writing in subscript, it will be a little bit difficult to see, right? So that's why they write like T bracket 1 or like T bracket 2, then T bracket 3. So it's actually the same thing, it's just that a different way of writing only. So it's the same thing as well if you got something like this. Okay, so now this is the part where I should be able to merge them together later. So, sorry, it's okay. Let us try to write for each row. Okay, so for anthem, so which means that imagine if I'm writing the third term, then you'll be writing T3. Fourth term, T4, T5, T6, and so on, right? So when we try to write like anthem, which means any term as we want, then it will be Tn. So it means if let's say it's the 50 term, then it will be T50. If let's say it's the 100 term, then it will be T100. Okay, so now I want you to imagine what is the term before it. What is the term before Tn? How do we annotate that? Okay, so if let's say it's the 50 term, then which means the previous term is 49, right? How do you get 49 from 50? It's going to be 50 minus 1. Am I right? Because when following the sequence, it will be 1 plus 1, you get 2, 2 plus 1, you get 3. So that's like order 1, 2, 3, 4, 5. So that's why the number that before 50, it will be 49. So if let's say we are using an n, then it will be t n minus 1. Okay? So what is the term that's after the n term? Then it will be the t n plus 1. Okay? because which mean if let's say it's 50 terms, then after 50 terms, then it will be the 51st term. So which means 51, you are getting it from 50 plus 1, right? So that's why tn plus 1. So it's the same thing here. If we are using the notation of a, then which means it's going to be an, then the term before it is like an minus 1. Then after that, this is an plus 1. Okay, so similarly, we can write it in tn plus 1 in tn in bracket as well. Apologize for that. Tn in bracket as well. Then tn minus 1, tn plus 1. Okay, so the same thing for the last one. So an minus 1. And the last one, we have an minus 2. Sorry, plus 1. Yeah, okay. So that's the idea of it. So I hope that you can understand that the n that we are using or the t that we are using, the term here meaning the term that we have in the sequence, which is not the same thing when we talk about the n. So we're going to look at the simple example here. Okay, for example, 1. So for the sequence 5, 8, 11, 14, 17, and so on, determine the following. Okay, so you realize this is a sequence. So how do you get each sequence? Is by adding 3 to the previous term. Am I right? Okay, so let's try to answer this very simple question. It's just for you to understand the idea that we discussed just now. So T3, yeah, so remember T3 doesn't mean that the term is 3, it means that the third term. So that's why 1, 2, 3, the third term in this sequence is 11. Okay, and then let's move on to B. So T6, so which means it's the sixth term in the sequence. So 1, 2, 3, 4, 5, 6. So in this case, it's 20. Okay, so C, T2 plus T5. So we are going to use the second term to plus the fifth term. So the second term is 8, and the fifth term, 1, 2, 3, 4, 5, is 17. So 8 plus 17, that gives us 25. Okay, so now let's move on to D. So we have 3T3. Okay, so 3T3, it actually means that 3 multiply the third term. So that's why when you try to look at this, then it will be 1, 2, 3. The third term is 11. So which means 3 times 11. And that gives us 33. Okay, and then move on to E. So 0.5 and T4 plus T6. Okay, so remember what you need to do is just substitute the terms, right? So 1, 2, 3, 4, that's 11, and 14, and the sixth term is 20. Okay, so you can get 34 times 0.5, which means it's half, then it's 17. Okay, then after that, F, T9, so you might need to find out yourself. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the ninth term will be the next term after 26, right? So that's why T9 is 26 plus 3, and that is 29. Okay, so I think this is very straightforward. It's just for you to understand what is that meant by the notation here. Okay, so now let's look at our second main idea, which is the recurrence relation. Okay, so a recurrence relation is an equation, okay, equation that recursively defines a sequence. So you can see the words there, recursive, right? So recurrence, so recursively defines a sequence. So recursively meaning like keep on repeating. So it's like a repetitive process. Okay, so that is if let's say you are given one initial term, or sometimes in a situation you might need more than one. When you are given the initial term, then you will be able to identify all the next term or all the further term by using a specific function of a specific rule of the preceding terms. Okay, so which means for some of the sequence that we have just now, right, then you can see that's like a rule. So recurrence relation help us to write down the relationship between the rule in a equation. Okay, so for example, this goes back to the example one that we did just now. So we know that obviously this is a sequence, right? Because when you try to see this, then you'll be able to guess what is the next subsequent term by observing the term, by observing the pattern here. So consider this sequence, you realize that each term is obtaining by adding 3 to the previous term. Am I right? So adding 3. Okay, so this statement actually tells us how the sequence recurs. So how the sequence continue to go on. So which means like for example, I know that what do I need to do for me to get the next term? It's always adding 3 to the previous term. So you can imagine that this process will just never end, right? If you can keep on adding 3 to the previous term until you even get like a very big number until you reach infinity. You get what I mean, right? So this idea for the statement that telling us how do you get the next term is called as the recurrence relation. Okay, so this is the idea. Or sometimes you can see that the question actually give like recursive row. They are basically the same thing. You can try to write down here as well. So the recursive row. Okay, they are basically the same thing. Okay, so for us to write a good recursive row, it's not like a correct recursive row. So the recursive row must consist of two main parts. So the first one is the pattern. Okay, or it's like the sequence or the relationship or the rule. Okay, the second thing is we must have the initial term. Okay, so that's the complete picture of a recursive row. So later we are going to do that together. So you can see that when you try to write the recursive row, right, you will need to show these two important parts. Okay, so let's start to practice for the part for the pattern first. How are we going to write it? Okay, so example 2. So we are going to write down the rule for each of the different situation here that given by the statement here. So each term is obtaining by, for example, this one is referring to the example 1 just now. Okay, so each term is obtained by adding 3 to the previous term. So how should you write it in an equation to, explain that you should add 3 when you want to get your next subsequent term? Okay, so you remember the idea that we mentioned just now. So we talk about the nth term, right? Because we are not be able to write like T1 equals to what, T2 equals to what. Because if let's say you try to do that, then what happens if let's say the question 1 T100, then you realize that you are just like stuck there, then not sure how are you going to find like T50 from T3 and so on. So that's why we learn about the notation just now, right? So we have Tn and then the n plus 1 term and also the Tn minus 1. Okay, so we are going to use this to help us to do that. Okay, so let's start with the one by using this. Okay, for me to get the current term, what do I need to do is I need to add 3 to the previous term. Am I right? So that's why you see, what can I write is that for me to get my n term, I need to use my previous term, which is the n minus 1 term, to plus 3. I hope that you get the idea. Okay, let me try to use a simple example for the first one first. So just now our example here starting from 5, am I right? So that's why it's like 5, 8, and then 11, 14, and so on. Okay, so let me try to use this simple example. So in this case, what we have is our T1 is 5, right? So you remember this is like one of the important parts. So you need to have the initial term. If you don't have the initial term, then you can't start anything. Okay, so then you see, how do you get the second term? Is by T2 is actually equal to 5 plus 3, right? What is your T5? Is your T1. It's your first term, right? You are using your first term and plus 3. So it's the same thing. How do I get my third term? It's by using my second term, which is 8, and then I plus 3. Am I right? So it's the second term and plus 3. Then how do I get my fourth term? It's by using 11 and plus 3. What's my 11? 11 is basically my T3, right? So that's why T3 is equal to T4 is equal to T3 plus 3. So you can see, right, as we move on, you can realize that how do we get our current term, which is the n term? You use your previous term, which is the n minus 1 term, to plus 3. So this is what is that meant by the recurrence relation. Okay, so now you might have a question here. If let's say I try to use n and n minus 1, can I use n plus 1 instead? The answer is yes, because it's the same thing, right? You see, if let's say I try to write in this term, for me to get the n plus 1 term, I need to use my previous term to 2 plus 3. What is the previous term to my n plus 1 term? Is my tn, am I right? So equal to tn plus 3. So which means these two recurrence mean the same thing. Okay? So it will be depending on the question. Sometimes they give you like specifically that they want you to actually denote your relationship by using the n term and n minus 1 term. Or sometimes they say that they want it to be in the terms of n plus 1 term and the n term. So you might need to follow the question. So if let's say that's not given, then both of them can be accepted. Okay, but you will see the difference, especially when we move on to finance in our unit 4, but that's not so important for now. So the idea is you get that they actually means the same thing. Because you see, right, what happened is if let's say my n is 1, so which means this become 2. So T2 equals to T1 plus 3, which is basically the same, right? Okay, so the idea is the order. All right. Okay, so let's try to look at the second one. So if let's say you need to subtract 5 from the previous term, then what is the rule for you to write? Yeah, so it will be, for me to get the current term, I need to use my previous term and then subtracting 5. So the same thing for the other part. So if this is all right, yeah. So depending on which one you prefer, but they are the same thing, and you should be familiar and you should understand that they are the same thing. So for me to get my term of n plus 1, I need to use the previous term and then minus 5. Okay, so that's the idea. So now let's continue. We are just going to write the first part, then the second part you can basically change yourself. I believe that you can understand the idea by now. Okay, so for me to get the current term, I multiply the previous term by 4. So 4 times at t and minus 1. Okay, so tripling, so you have double, right? So tripling is like 3 times the previous term and adding 5. So in this case, you have like 2 operations that you need to do. So which means for you to get the current term, we need to times 3 for the previous term and get this answer and add 5. Okay, so in this case, it's okay if you are not putting in any bracket, because we know that multiplication and division comes before addition and subtraction, right? So that's why when you look at this, then the person should understand that you need to times 3 first, then only plus 5. Okay, then increasing 40% to a previous term. So how are we going to do this? Yeah, so 40%, which means when we try to write in decimal, then it will be 0.4. So it's like increase 0.4 to a previous term. 100% is your original, right? So increase 40%, which means 100% plus 40%, then that's going to give us 140%. So Tn will be equal to 1.4 Tn minus 1. Okay, so that's the idea. Okay, then or you can basically understand it as if you need to take the 100% for the previous term, then after that you plus another 40%, right? So that's why when you try to add them up together, that's just give you 140. So that's why when you change into decimal, that's like 1.4. Because you can't press like 140 times the number, right? You know that you will be dividing 100. So whenever you want to do percentage, then you need to divide by 100 for you to get the decimal, right? So that's the idea. Okay, then the next one, decrease 20 from the previous term and add 2. Okay, so the same thing, 100% is the original percentage. So decreasing 20%, which means that you are deducting 20%, and what you left is the 80%. So that's why to get the current term, you times 0.8 for the previous term and then add 2. Okay, so that's the idea. Don't worry about this percentage for now, maybe. So, I mean, we can discuss it further if you find it difficult, but you should be familiar with this. Like, when we say plus 40%, then it means like times 1.4, then minus 30%, then it will be times 0.7. You should be pretty familiar with this idea. I hope that your foundation is like okay for this, like percentage, right? Yeah, that's like easy thing. Okay, so adding the two previous term. Okay, so this is harder one. So you see, when we say that adding two previous term, what is that mean? Which mean that you will need two terms beforehand for you to find the next term. Am I right? So that's why by looking at this sequence, then you can actually find out if, let's say, because I have the two terms in front, am I right? So that's why, which means for me to get Tn plus 1, I need to use these two terms plus together. So the first idea that you can do, which is by doing Tn plus 1, it will be Tn plus 1 will be equal to the addition for the previous two terms. So Tn minus 1 plus Tn. Okay? Alternatively, if let's say you want to use the n term in front, then which means that you will need to think of what is the two terms beforehand. So Tn, the one that before is Tn minus 1, right? You need one more before so that you can add them together. So n plus 1, the one that is before that, it will be Tn minus 2. Okay? So like for example, if let's say this is 50, then this is going to be T49 and T48. So 48 is just two places before 50. So that's why 50 minus 2. Okay, then the last one, squaring the previous term. Okay, so I think this is not hard. So which means for us to find Tn, then we need to use the previous term and then we need to square it. Okay, so that's the idea. So let me talk about something about the words that you see just now, the first order linear or recurrence relation. So I'm going to explain it again in the future lesson, but since I put in the example here, so just for your understanding. Okay, so first you can see the words is mainly made up of two parts. So the first one is the first order. The second part is linear. So if you can recall the word linear, right, it actually means like degree 1. So which means you are not dealing with anything that's like you need to square or you need to, power 3, power 4, square root or so on. Okay, so the thing that we are dealing with is just linear. So for example, this last one eventually wouldn't like really come out in your exam because this is like a quadratic, so-called a quadratic function already, because you have degree 2, like power 2 here. Okay, then the second thing is they talk about first order. So first order meaning that the recurrence relation that we create is just based on one previous term. So which means that in our recurrence relation, we don't involve like more than one previous term. So in this case, this one is not in our syllabus as well, but you can find it out in your exercise, and I think it's a good one for you to practice, for you to understand it, because it will be very helpful if we move on to like finance and so on. But just to tell you that for all the application that we are going to solve under this particular topic, right, it will be based on first order linear only. So which means like for example all this. Okay, so as you can see, for all the relationship here, right, what we are using is just like first order. So you see, how are we going to get Tn? It's just by using Tn minus 1. Sorry, this is 1, right? I hope that my handwriting, yeah, 1. So Tn minus 1, Tn minus 1. So we didn't use more than one term for us to identify the subsequent term. So that's first order. Then linear, you realize that all of them are in degree 1, so which means there's no squaring and those stuff. So that's why these are all the things that we will be encounter more in our example later. Okay, so that's the idea. So now let's go on to example 3. Okay, example 3, write down the recursive rule for the sequence given in page 1. Okay, so I'm going to focus in the part for the first 5, then the rest one, especially the first 3 lah, the rest one wouldn't be related so much to your syllabus, but it's good that you can understand. Okay, so remember, let me remind you again, the example 2 just now is like a practicing on the rule part. So remember that when we say that we need to write a good recursive relation, we need to have two things. The first one is the pattern, the second one is the initial term. So yeah, remember that later we need to write our initial term. So in this case, you can see it's plus 3, right? So that's why it's going to be Tn and then equal to Tn minus 1 plus 3. Okay, so let me repeat again. It's the same thing if let's say you want to write like this. Okay, the idea, yeah, so I hope that you don't, there's no question that asking like, teacher, can I write like this instead? Okay, so they are just the same thing. But normally for your recursive rule, it will be easier that you write like this because, I mean, when you try to look at this, then you are thinking like you want to get the current term, you use previous term to plus 3. If you, I mean, the idea is just the same lah, but when you write tn plus 1, then it gives us the idea where if you want to get the next term, you use a current term to plus 3. So, I mean, there's nothing wrong, right? If you want to get the next term, you use a current term to plus 3. It's the same thing like if I want to get the current term, I use a previous term plus 3. Okay, so remember the initial term, so T1 is equal to 2. Okay, if you are not given, if you are not writing the initial term, then the person wouldn't know where's the number that you want to start, right? So this is the important part for your recursive rule as well. Second one, minus 15. So Tn will be equal to Tn plus 1 minus 15. Okay, then after that, move on for the next one, times 2. So that's why we have Tn will be using the previous term and multiply 2. Okay, so for the fourth one, it isn't really like a recursive relation. It's just more onto like a sequence. So which is, okay, you can imagine, right? If I want to find the 10th term, I actually don't need to know the 9th term because I see at the first place, so 1 square, then 2 square, 3 square, 4 square. So how do you get 16? It has no relationship with the 9 previously. Am I right? You are not adding or you are not multiplying with the 9. So basically in this case, right, you can imagine if let's say you were to find the 10th place, then you are just doing 10 square and then 100. So that's the idea. So that's why in this case, your Tn will be actually just equal to where's your position. So first term, so 1 square. Second term, so 2 square. Third term, so 3 square. So that's why it's going to be n, then power 2. So it's the same thing like if you want to find T15, then it's going to be 15 square. So that's why this is not really a recursive that you are using the previous term to help you to solve. So this one is, it's not a linear. I'm not going to talk about this here. It's going to be a little bit too difficult if we were to use like our intuitive to solve this. Okay, the last one we can do that. So it's just by adding the two previous term, right? So depending on you, the first option that you can try to do is if you are using Tn, so your previous two terms, it will be Tn minus 1 and then Tn minus 2. Okay, so the idea is if you want to get the third term, you use the second term to plus the first term. So that's the idea. If you are using Tn minus 1, if you want to use Tn plus 1, then what's your previous term? It's going to be Tn. Then your previous term is going to be Tn minus 1. Okay, so this is a bit similar with the example 2 that we did just now. Okay, so that's pretty much the idea. Let's move on to the next example. Okay, number 4, 5, 6, and 7. Yeah, it's basically for you to get used with the recursive equation that you understand how do you write down your term. Okay, so a sequence is defined by n term equals to n minus 1 term plus 3 with the initial term which is equals to 5. Okay, so you see every time when you try to write it, it must consist of your sequence, your rule, and also your initial term. Okay, so that's why this is like the two main component for a recursive sequence. So determine the first 5 term. Okay, so you can realize that the first one is given already, so which means your initial term, which is your first term, is 5. Okay, so how are we going to get term 2? So Tn, right? So the n is 2. So n minus 1, which means 2 minus 1 is term 1. So how do you get the second term is by using the previous term and plus 3. So in this case, we have 5 plus 3 and that gives you 8. Okay, so after you get familiar, then you don't need to write down the working, but I will encourage you to do it for the first time, so for your understanding in future. So how do you get your third term is by using the previous term then plus 3. So the previous term is term 2, which is 8. So that's going to be 8 plus 3 and that gives us 11. Okay, so T4, the third term and then plus 3. So that's why we have 11 plus 3 and that gives us 14. So the last one, T5. So we use the fourth term plus 3 and that is 14 plus 3. So that gives us 17. Okay, so in this case, the first 5 terms for the sequence is 5, 8, 11, 14, and 17. So you can realize here is that all the difference is the constant one, which is 3. Okay, so now example 5. All right, example 5, the sequence is defined by t. Yeah, so you can see this is tn plus 1 already, right? So yeah, I hope that you can get yourself familiar with both of this. Okay, so the first term is given 6. So same thing, write down the first 5 terms. So t1 is 6. Okay, so you will realize that the idea is just the same. So Tn plus 1, so which means is T2. So which means Tn plus 1, if n plus 1 is 2, which means what is your n? It's basically 1, right? Because 1 plus 1 to give you 2. So your n is 1. So which means how do you get T2? It's by 2 multiply your T1 and then plus 3. So in this case, the T1 is 6, so 2 times 6 and then plus 3. Okay, and that is 15. Then we'll move on. So how do you get the third term? Is take the previous term and then times 2 and then plus 3 as well. So you can see n plus 1. If let's say n plus 1 is 3, which means your n is 2. So that's why Tn is T2 lah. So equal to 2, then 15 plus 3. Okay, so 30, so 33. So next one, T4, is going to be 2 times T3 and then plus 3. So 2, T3 is 33 and then plus 3. Okay, so that's 66 plus 3, so 69. So last one, T5 equal to 3, T4 plus 3. Okay, so this one you need to calculate a bit. So again, do not use your calculator. Try to, avoid yourself from doing that. So 69, so think of 69 times 2 or 69 plus 69. So that's going to give you 138. So 138, so 141. Okay, so that's the idea. Okay, so now same thing, write down the first 5 term. So we start with 6, 15, and then 33, 30, 69, and then the last one is 141. Okay, so now let's move on to the next one. Okay, example 6, a sequence is defined by Tn plus 1 equal to 2 power n Tn with T1 equals to 5. Determine the first 5 terms of this sequence. Okay, same thing. So when you realize that's like power kind of thing, you know that this is actually not a first order linear recurrence. So this is basically non-linear. So like the one that we skipped in example 3 just now. Okay, but I feel like that one is because of you are given the sequence. Then if I were to ask you to write recursive, then it will be a bit difficult. But in this case, it's actually substitution. I think it's a good example for you to understand that what you are doing is just following the rule. Okay, so yeah, let's try to understand this. So we have Tn plus 1. So for you to get the next term, then you get the you get a current term. So if you want to say that this is a current term, then you are taking a previous term, then times with 2 power n. Okay, so T1 is 5. So again, the n here basically meaning like what is the position of your term only. Okay, so determine the first 5 terms. So same thing, let's try to find our T2. Okay, so if Tn plus 1 is 2, meaning Tn is T1. So which means at this place, right, what is our n? Is 1. Am I right? So that's why 2 power 1 and then T1. Let me explain again. Because Tn plus 1, so that's why we are finding T2, right? How do you get 2 is 1 plus 1. So that's why in this question, our n is 1. So that's why what do you need to do is like 2, n is 1, t, and then n is 1. So this is how you get 2 power 1 and times with T1. So that's going to give us 2 power 1, which is 2, multiply with T1, which is 5. So that gives us 10. Okay, so let's try to do one more. So if let's say I'm finding my T3, so which means that what is my n? So n plus 1 equals to 3. So which means my previous term, which is the n, is going to be 2 because 2 plus 1 equals to 3, right? So what are you writing down for the n? It will be 2. So 2 power 2, t power 2. Okay, simple as that. So 4 and then T2, that's going to be 10. So that's why it's 40. Okay, next one, the fourth term. Okay, so for you to get the fourth term, you need to use the previous term, which is T3. So in this case, your n is 3. So 2 power 3 and then term 3. So it will be equal to 2 power 3, then that gives us 8. Then after that, T3 is 40. So that is 320. Last one, T5. Okay, So the previous term is the fourth, so that's why 2 4 T4. Okay, then equal to, so 2 to the power of 4. Yeah, so you should practice that. So 2 times 2 times 2 times 2, so that gives you 16. T4 is 320. Okay, so for this one, yeah, you might need to use a bit of your calculator to help you to do that. So I mean, if this come out in your exam, then you can always write down at your working here. Okay, you should know like how to do like normal multiplication if you get what I mean. Okay, so you are getting 5120. Okay, or you can try to split it out like 320 times 4 times 4 is the same thing. Okay, so now let's try to write down our term. So 5, 10, 40, and then 320, and the last one is 5120. Okay, so that's the idea. I hope that you get what is that meant by the end thing here. Okay, so one more example that's similar like this, you are using the and. So let's look at example 7. Okay, a sequence is defined by Tn equals to negative n times the previous term. So given your first term is 2. Okay, so same thing. Let's try it out. Tn negative n, Tn minus 1. So the first initial term is 2. Okay, so now let's try to write down. So initial term is 2. So for us to find T2, so now, okay, you should realize the difference between, I mean, when you are given like the Tn plus 1 or the Tn. So if you are given like the term like Tn and then negative n minus 1, so in this term, when you are finding T2, then what's your n? Your n is basically 2, am I right? So what you are writing in this place is like negative 2. Okay, if this they are given like negative n minus 1, then which means you should get negative 2 minus 1. It's just basically following the sequence then following the n that you are solving. So T2, so that's why my n is 2. So Tn plus 1 is going to be 2 minus 1, so that's why times my first term. So that equal to negative 2 times 2. So that is negative 4. Okay, so move on to the next one. If I want to find T3, so T3, so that's why n is 3. If n is 3, negative n, which means negative 3. So Tn minus 1, the previous term, right? So T3, 3 minus 1, you can get T2. So that's why in this case, it will be negative 3 multiply my second term, which is negative 4. And that will give me 12. Okay, so move on T4. So the same thing, negative n, my n here is 4 now, so negative 4. So that's why Tn minus 1 is T3. So equal to T4 and then times with T3 is 12, and that gives me negative 48. So move on, next one, T5 will be equal to negative n, so negative 5, Tn minus 1, 5 minus 1, so T4. So negative 5, the fourth term is negative 48. So 48 times 5, so 48 times 5, 40, so 240, sorry for that. So 240. Okay, so that's the idea of it. Okay, so now let's try to write down our first 5 terms. So 2, negative 4, 12, negative 48, and then 24. So, 240. You realize that that's like alternate sign that actually caused by this negative. We're going to look at this in a much more detailed way when we look at GP in future. Okay, don't worry about that. But it's basically because of you have a negative factor, negative multiple here. So that's why you imagine like positive, you multiply negative, that gives you negative. Then negative multiply negative, so that's why you get back positive. Positive multiply negative, then you get back negative. So you have your answer at positive, negative, and so on. So this is why. Okay, so the last example, so this is like this is not the first order as well. This is the second order. Okay, example 8. So Tn plus 2, when you look at this sequence, right, you realize that it involves 2 terms before. Okay, you can see, right, Tn plus 2, then Tn plus 1 is the term before this. Then Tn is the term before this one. So which means that if you need to get what you want, you need to have 2 previous terms. So this is like a second order linear recurrence relation, which is not in our syllabus as well. But like what I say is good for you to understand for your recurrence relation, but you doesn't really need to know how to write this recursive lah. Okay, so T1 and T2 are both 5. So you can see that the initial term that you need is actually more than 1. Because if let's say they only give you T1, then you wouldn't be able to do that because you need 2 previous term that only you can find the third term that you want. So find the first 5 terms, so which means we would only need to work for third, fourth, and fifth. Okay, so for T3, so you can see n plus 2 now is represented by 3. So what's your n? It's going to be 1 because 1 plus 2 equals to 3. Am I right? So that's why 2 times T1 plus T2. Okay, because n plus 1, so which means 1 plus 1. So equal to 2, T1 is 5, T2 also is 5. So 10 plus 5, that's 15. Then the next one, let's look at T4. So n plus 2 equals to 4. So your previous two terms, that's going to give you 2 and 3, right? And that is correct because when you see n plus 2 gives you 4, which means your n is 2. So it's going to be like 2 and 3 here. So 2, T2, and then plus T3. Okay? You see, right, in this question, you can't simply change the place, right? So you can't write T3 here and T2 here, yeah? So please understand that because for this term, you need to multiply 2 and that's going to give you a different answer if you substitute the wrong thing. Because in this case, they already specified that it's the previous second term is going to multiply by 2. Then the previous term is going to be just adding it in front. So that's why it's supposingly it should be like 2 here and then 3 here then to get your fourth answer. So equal to 2. So T2 is 5, T3 is 15. So 2 times 5, 10, so 25. Okay, so move on to the last one, T5. So n plus 2 is equals to 5. So 3 is, n is 3. So 2 times T3 plus n plus 1, so T4. So that going to give us the third term is 15. And then T4 is 26. So this one is not hard as well. 2 times 15 is 30. 30 plus 26 is 56. Okay, so now let's look at two more examples, like for the solving question. Okay, example 9. So you see this is like a different alphabet that they use here. Okay, so yeah, let me remind again. So it's not always T. It will be depending the question that is given. So WN plus 1 is equal to 3WN minus 4. Okay, so this sequence can be used to generate a sequence. So find W5 if W3 is -1. Okay, by looking at this, right, you are given the third term, which is -1. So by looking at this recursive rule, right, you should be able to realize that from W3, you only can get W4. Am I right? Because if you are substituting W3 here, so 3 plus 1, then this is how you get W4 here, right? So you can't straight away jump to 5. So that's why in this case, it's just like W4 equal to 3, and then n plus 1 is 4, so that's why Wn, it will be W3 minus 4. So 3 times -1 and then minus 4. So -3 minus 4, that's -7. So same thing, we need to continue one more to find the fifth term. So W5 is equal to 3 times W4, right? Use the previous terms times 3 minus 4. So that's going to give us 3 times our fourth term, -7 minus 4. So -24 minus 4 is -25. Okay, so that's very straightforward for example 9. So now example 10. Okay, the sequence is defined by the recurrence relation. Now you see is A. Okay, so yeah, that doesn't matter, right? As what I said. So an, the n term is equal to 2a, the previous term, plus 4. Okay, so the question gives us that a4 is 100. So the question wants us to find the fifth term and the first term. Okay, the fifth term will be easier because you are given the fourth term. So let's solve that first. So a5 is basically equal to the previous term, right? So an is a power a5. So 5 minus 1, that is 4. So which is 2a4 plus 4. Okay, and that equal to 2 and then 100 plus 4. So from here, then you are able to get 204. Okay, So now the problem is your first term. Okay, so now you'll be able to, imagine the whole situation, how is that going to look like, and we try to solve it by using like a common sense of thing. Okay, so which means in this case, right, you imagine that what are we having is like A1, A2, A3, A4, and A5. So in this case, we already have our A4 and A5, right, which is like 204 and 100. So how are we getting all these terms? It's like multiply 2 and plus 4. Am I right? So for all these terms, it's like multiply 2 and after that we plus 4. So this is how we can see the relationship between 100 and 204, right? So when you times 2, then you get 200, then you plus 4, then you get 204. Okay, so now what do you need to do here is actually imagine what happened when you do, when you try to do everything like in the reverse direction. So which means now when we try to look at this part, how can we get 100 from 204? So you multiply 2 and plus 4, right? When you go reversely, then which means what happened? You need to minus 4, right? Because you plus 4. So now to undo this process, we minus 4. Then what is a process that if let's say we undo if let's say we undo multiply 2, then it will be divide 2. Am I right? Then you can always try to check again with your number. 204 minus 4, I get 200. 200 divided by 2, I get 100. So that proves that my idea of undoing the process is correct. So now I can continue by doing the same thing because they are following the same sequence, right? All of this is times 2 plus 4. So this should be the same as well. Multiply 4, then divide 2. So 100 minus 4, then I get 96. So 96 divided by 2, I can get, yes, that's 48. Okay, so yeah, you can always try to check and see 48 times 2 and plus 4, are you getting 100? That is right, so that's why this is correct. So we move on again. So divide by, how come I keep on saying divide 4? Okay, minus 4 and divide 2. So that's why in this case, 48 minus 4, we get 44. 44 divided by 2, we get 22. Okay, so same thing if you want to check. So minus 2, we get 44. 44 plus 4, that gives us 48 as well. So that's why that's correct. Okay, so we are very near to our answer already last time. So negative 4 minus 4 divided by 2. And what can we get? Minus 4, 18. 18 divided by 2, which is 9. So you can see 9 times 2, 18. 18 plus 4, 22. So that's why that's correct. So in this case, our A1 is just basically equal to 9. Okay, so that's the idea. You don't really need to solve it by simultaneous and so on. So in this case, you can just try to use the idea of like undoing the whole process to do this. Okay, so now let's try to look at the last example. All right, so this is slightly harder that you might need some of your knowledge in simultaneous equation to help you to solve this. Okay, so I hope that you are familiar with this idea. If you are not, then please remember to go and search it yourself. I'm not going to repeat this unless there's a lot of people don't know how to do this. Then maybe we can try to discuss it next week when we meet in the class. But you can always try to search this out online. So simultaneous, and the thing that you are dealing with is just linear. So it's like simultaneous linear equation. Okay, so you can try to search it out if you don't know how to do. So simultaneous linear equation is as if you are given equation. Normally, we are just dealing with like two variable. So you have two unknown that you need to solve. So you know that if you have two unknown, then you can't solve it by using one equation, right? So you need two. So you need at least two equations for you to solve two variable. So that's why in this case then, which means that later you can see that we are going to form like two equations. So that's consisted of two different unknown. Then we need to use some skill to help us to solve that. Okay, so 27, 107, 420 has a recursive rule that's in this form. So determine A, B, and T6. Okay, so in this thing, then we are not given the rule. So which means we are the one that need to solve for the A and the B. So how are we going to do that? So let's see. In this case, you are already given the initial term, right, which is 2. Okay, so now let's see, if let's say I need to find my T2, normally how do I do that? So my T2 is substituting into this, right? So that's why if n is 2, then which means n minus 1 is 1. So that's why it's going to be A times T1 and then plus B. Am I right? So now let's try to substitute the number that we have here. The second term is 7. So 7 equal to A. My T1 is what? 2, right? And then plus B. So in this case, what I can get is 7 equal to 2A plus B. So this is my first equation. You realize that we can't solve because there's two unknown A and B. Okay, so this is why we are talking about simultaneous. So now the same thing, we can move on. It's depending on you which one you want to use. I mean, but if let's say you want to deal with an easy number, a smaller number, then obviously we try to choose the first three rather than, using 107. But the idea is just the same. Yeah, you will be getting the same answer. If you are not getting the same answer, then which means something is wrong with your working. So now let's try to use a third term. So the third term equals to A, then T2 plus B, right? Okay, so what's our third term? 1, 2, 3. So that's 27. Then our term 2 is 7, right? So substitute 7 and then plus B. Okay, so in this case, I will get 27 equal to 7A plus B. Okay, so now this is your second equation. So now by having two equations, then I can solve for these two unknown. So by looking at this, you can see you have BB. So obviously you can try to use elimination to do this. If let's say you want to use substitution also can, it's just the same thing. Okay, you should be familiar with these two methods. So the first one is called as substitution. The second one is called as elimination. So there's no statement to say that which one is better and so on, but it's just that depending on the questions and what you want to solve, then you decide which one is better, which one is more suitable for you. So in this case, because we can see that's BB, they can eliminate each other, so that's why it's easier to do elimination. But substitution is not too bad as well. You can just put like B equals to what, then you substitute the B place here. Okay, so when I do elimination, so since this is 2A, 7A, I prefer to get a positive number, so I'm going to use the second equation to minus the first equation. So what I can see is 27 minus 7, then I get 20. Then 7A minus 2A, that's going to give us 5A. So B minus B, then I don't have B. Then this is how I eliminate B. So this method is called as elimination. So from here, then I'll be able to get A equals to 4. So now what I need to do is substitution back into the equation. So depending on you, whether you want to use 1, 2, is just the same. So I will choose 1 because the number is easier rather than 27 or times 7, right? So 7 will be equal to 2. We substitute the A that we found just now, so 4 plus B. So you see, you're left with one variable again. So from here, we can solve that B is -1. So in this case, our A is 4, B is -1. So let's try to rewrite the recursive equation. Tn equals to A is 4, Tn minus 1. So B is -1, so -1. Okay, so that's the idea. So T6, now you have 1, 2, 3, 4, 5 already, right? We can straight away solve for T6 is equal to 4 times T5 and then minus 1. So T5 is given 427 minus 1. Okay, so in this case, we can, I'm just going to use calculator to solve that. But that's not too bad as well. So you can, that's possible to come out in your exam because this is like, easy calculation that you can try to do, right? Like 8, after that 1, 0, then 1, 7. Okay, so 1708, then yeah, at the end I'm still doing calculation. Okay, so that's the idea. Okay, then you can get the sixth term. Alright, so I hope that you can understand the idea, and I'm going to talk about how are you going to use your calculator to generate the recursive formula and maybe how to solve your simultaneous equation with your scientific calculator and TI Inspire. But like what I said, this is there is a possibility that it will come out in your calculator free paper one. So that's why it's super important for you to understand how to do that without using your calculator. So that's why I'm like splitting this into like two videos. So after the first video, you can actually attempt all your exercise. Then you only use your calculator to check your answer. Okay, so that's basically the idea. So remember to watch your second video for the calculator, and yeah, I'll see you in next week. Okay, thank you.